let's say we have a kid on a slide. Given the mass of the kid, the angle of the slide, the coefficients of friction for static and kinetic, find the acceleration of the kid on the slide. Well, step one is draw a free body diagram. So if we say the kid is a block on a plane, mass times gravity pointing down, normal force pointing perpendicular to the surface, and then we'll have a friction force. Well, we know that since the kid's weight is trying to pull him down the slide, then the friction force will oppose that. So friction force has to point up the slide. Then next we assign a coordinate frame. Well, we put X in the direction of motion, Y goes perpendicular. And we know that this plane angle is theta, then the angle between mass, gravity, and the normal force is also theta. So we can do step 3, which is break this into components and write the force equations. So in the y direction, sum of the forces in y equals 0 because the block does not jump off plane. So that is going to equal n, pointing up, minus component of the weight that points into the plane, which is this component, the cosine. With those numbers, we got n equals 30 times 9.81 times cosine of 40 degrees equals 225 newtons. So then the friction forces, friction equals mu times normal force. So for static, that equals 0.6 times 225, which equals 135 newtons. And then the kinetic is 0.3 times 225, which equals 67.5 newtons. And then the x forces, sum of the forces in the x direction equals mass times acceleration. That equals the component of the weight that's pulling down the slide, which is the sine component, mg sine theta, minus the friction force that points up. So to check static, we'll compare. So if it doesn't slide, acceleration would be 0. So we compare 0 to mg sine theta minus static friction. So this will be 189 minus 135, 54, which is greater than 0. So the kid slides. So next we'll do dynamic. Here we know that acceleration equals mg sine theta minus kinetic friction over the mass. And this equals 189 minus 67.5 over 30 equals 4.05 meters per second squared equals acceleration. So to solve the problem, first we drew the free body diagram with all the forces Then we assigned a coordinate frame. Third, we wrote down the force equations, the y direction, x direction, found values. Then we checked static to see if the kid slid. He did slide, so we did a kinetic check. Found his acceleration. Now, if for some reason he didn't slide, like say it was less than 0, then acceleration would just be 0. You wouldn't have to do a kinetic check because you'd know he doesn't slide. And so then finally, we solved out for the answer.